Hey guys, welcome to Pre-Calc Lesson 3.4, Writing Equations from Graphs. Before we start writing equations, let's review some topics from days 1 through 3. In this first example, I want you to sketch f of x equals x cubed minus 3x squared plus x plus 9 over the closed interval x is an element of negative 3 to 8. So what that's going to do is that's going to set our window. X min is going to be negative 3 and x max will be 8. I'm going to put this into y1. Probably want to put y2 equals 0 while you're at it. Now, we're going to have to adjust the window a little bit. I know my x min here is going to be negative 3 and my x max is going to be 8. The thing is with this graph, if you adjust your y max and your y min too much, you're going to get something that sort of looks like this. And it's really hard to distinguish what's going on here. I'm guessing there's a relative max somewhere and a relative min. Because when I see a cubic, I'm thinking this shape right here. So what you want to do is you want to adjust your window so that you can see the relative max and the relative min while it's on its way to the tails. And my sketch looks roughly like this. I know there's going to be an endpoint there and there's going to be an endpoint here. And what's nice about this, when they give you a closed interval, you don't actually have to see this on the graph. You know it's going to end at 8 and it's going to end here at negative 3. So what I would do first is I would go to my calculator, go to second table to get this coordinate right here. That was negative 3, negative 48 as I'm looking at my table. And this one up here is 8, 337. 8 comma 337. Now what I would do is I would find my root, find my relative max here, and find my relative min there. So using second calc intersect, I'm going to find my root, and I'm going to round to nearest tenth. Negative 1.3, comma 0. My relative max, it looks like I have it on the wrong side of the axis there, but it's going to be 0.2, comma 9.1. And my relative min here is 1.8. 6.9. Now that I have my key points, I can go ahead and answer these questions. Now, it doesn't specify set notation or interval notation. Usually we like to follow the format of the domain. So I'm going to answer all of these in interval notation, but if you use set notation, it's not wrong. First, where does the minimum occur? It should say the minimum. And the minimum is here. It's not a relative minimum. It just says the minimum. So it's going to be that one. It occurs at negative 3, negative 48. What is the range? The range, remember, it's a set of y values. So you have to look for your max and your min. And that's going to be the range right there. Range, remember, the y value. So I have to say y is an element of, the minimum value is going to be negative 48. The maximum value is going to be 337. I'll use brackets because it includes those points. Where is f of x increasing? So it's going up. Open circle to here, open circle to there. So I have to use negative 3 to 0.2 and 1.8 to 8. Back to x's now. So x is an element of the interval, parentheses, negative 3, comma, 0.2, close parentheses, union, the other interval, 1.8, comma, 8. Where is f of x greater than or equal to 0? So that means above or on the x-axis. Above or on, that's on, and all of this stuff is above. So that's going to be from negative 1.3 to 8. X is an element of bracket, negative 1.3, comma 8, with another bracket. And give coordinates of all relative extrema. That word extrema basically means a relative max or min. Relative, so I'm looking for a hill or a valley. That's not a relative max, that's not a relative min. So it would just be these 2 points right here. 0.2, comma 9.1, and 1.8, comma 6.9. All right, let's do some sketching. Sketch the following without a calculator. F of x equals x times x minus 2 times x plus 1 squared. So first thing to do here is probably identify your roots. I think that's going to be the easiest to see. X equals 0, x equals 2, and x equals negative 1. But notice that's going to be a double. This is squared. So I'm going to make note of that, double. Remember, that's going to affect the behavior of your graph. Now, the y-intercept, this is pretty easy because remember what we said. If 0 is a root, then the y-intercept is always going to be 0. Okay, let's talk about our tails or end behavior. Well, to do that, what I want to do is figure out what the first term would be if I multiplied x times x times x squared. X times x times x squared. That's going to be x to the fourth. So if you were to multiply all this stuff out, I'd have x to the fourth plus a bunch of stuff. What that means is I have a positive even, and what that tells me is both tails are up. And that's all I need. Now let's sketch it. I've got 0, I've got negative 1, and I've got positive 2. And it's got to go through these 3 points. There's negative 1, there's 0, there's 2. My tails are both up. This right here indicates it's going to bounce. So it's going to do something like that or something like that, depending on which way it's coming from. So negative 1, it's going to be a double. Comes down here, turns around, goes up, turns around, goes back down through. And there's my semi-accurate sketch of that polynomial. Okay, my next one. I'll do this in a different color. Notice what we have here. Cubed and squared. So if you were to multiply all of this out, you'd have 3 times x cubed times x squared. That's going to give you 3x to the fifth. Plus a bunch of stuff. And then what would the last term be? The last term would be 3 times 1 cubed times negative 2 squared. Now you can do that in your head, or when I do the y-intercept, you're going to see I'm actually going to show all of that work, so maybe I'll do that first. But let's get our roots, because it's already factored. Pretty straightforward. X equals negative 1, and that's what we call triple root. X equals 2, and that's a double root. So there's only 2 distinct roots. My y-intercept, if you don't want to multiply it out up above, here's how you do it. Remember, to get the y-intercept, x equals 0. So basically you replace your x's, I should say, with zeros. And what do you have left? You've got this, 3 times 1 cubed times negative 2 squared. So it's going to be 3 times 4, that's 12. There's your y-intercept. Tails. So I have an x to the fifth, positive x to the fifth. So I know it's going to do something like that. Now let's sketch it. I have negative 1. I have positive 2. My y-intercept is 12. So I'm just going to put a mark here and label that 12. So I know it's got to go through negative 1, 12, and 2. Now look at your tails. This goes like that, and that goes like that. So the double root is going to bounce. The triple root is a pass-through, but it flattens. Kind of looks like this. Actually changes concavity. The double root is going to bounce. So it's either going to look like that or like that. So we get to negative 1. That's my triple. So I know it's going to pass through, but it's going to flatten out. Something like that. That's going to go up beyond that, come down, bounce on that root, and then go back up. So there's a fairly accurate sketch. When you do this, it has to be clear that this is not passing straight through, it's changing concavity. So it's got kind of a bend like that and then a bend like this. Okay, let's get into writing equations. So I want you to write the equation for this graph. Basically what you need to do is identify all your roots and your y-intercept. Notice your tails. So basically I see it has 3 roots. I notice these tails, so I recognize this as a positive cubic. What I want to do first is identify the key parts. Roots. X equals -6, -2, and 7. My y-intercept, y equals -2. So I need to build these factors, right? We're working backwards. Usually I give you the factors and you get the roots. Now I'm giving you the roots and you give me the factors. So I'm going to write y equals, I'm going to put an a here, and you can see why in a second. If my root is -6, my factor is going to be x plus 6. Because remember, the root's going to be the opposite of what you see in the factor. So that's going to give me x plus 6. If my root's -2, that factor is going to be x plus 2. If my root is 7, that factor is going to be x minus 7. Now here's the issue. If you just put this into your calculator, you would get something that hits on those roots without a doubt, but that would not be your y-intercept. Actually, if you look at what your y-intercept would be if we don't do anything, the y-intercept is going to be 6 times 2 times -7. All right, what's that, -84? That's not even close to this. So that's why I put an A here. It actually has a vertical stretch. So what do you do to figure this out? Well, I'm going to show you the long way first. I'm going to give you a little formula that if you can remember, it's going to make these a lot quicker. So the issue here, to get the y-intercept to be -2, you have to think about this coordinate here, 0, -2. This is your x, there's your y. So one way to do this would be to put a -2 over here for your y, call that A, and then put zeros in for all of your x's. So that's a 0, that's a 0, that's a 0. So basically what you just end up with is 6 times 2 times -7. Now what I'm going to do before I actually multiply this stuff together, because here's how we're going to derive our formula. I'm going to divide by 6 times 2 times -7. Divide by 6 times 2 times -7. So A equals -2 over 6 times 2 times -7. Well, what is the -2? The -2 is my y-intercept. So you can think of that as the y-intercept. Where does the 6, the 2, and the -7 come from? It's your product of factors. So let's jot that formula down. A equals the y-intercept divided by the product of factors, because basically you set x equal to 0. All right, so if I actually calculate that, I get -2 over, what's that, 12 times -7, that's -84. And you can simplify that fraction to 1 over 42. So that now has to go here. Let me rewrite that equation with everything in it. Y equals 1 over 42 times x plus 6, x plus 2, x minus 7. Now this is calculator inactive, but if you're doing homework, you can actually put this into y1, and you will see the roots indeed are -6, -2, and 7, and your y-intercept is -2. All right, let's start going a little bit quicker now. Example 2. Let's identify our roots. X equals -5, and notice that's a double. 3 and 8. Y-intercept, -5. Okay, so let's start building the equation. Y equals your value of A times x plus 5 squared, again because that's a double root, so you gotta square it, times x minus 3 times x minus 8. How are we going to get our value of A? It's going to be the y-intercept, -5, over the product of factors. So basically what we do is we set all those x's equal to 0 and multiply what's left. That's going to be 5 squared times -3 times -8. So I get -5 over, and do some quick mental math here. That is 600. And 5 goes into 600 120 times, so this is -1 over 120. -1 over 120. So there's your equation. All right, a couple more. 2 more. Example 3. Let's write this equation. First, let's get our roots. X equals -8, -4, and 6. And notice 6 is a triple. How do I know that? Flattens out, passes through. My y-intercept, y equals -5. All right, so here's my equation. Y equals, I'm going to have a value for A here. I'm going to leave some room. X plus 8 times X plus 4 times X minus 6 cubed. All right, so now your value of A equals the y-intercept over product of factors. 8 times 4 times -6 cubed. So remember, this is calculated and active. I'm just going to do that quickly, and I get -6,900, carry the 1, 12. Okay, I'm joking. You're not going to have one that difficult. That's calculated and active. I'm going to simplify this. Actually, it doesn't simplify at all, so that's it. Writing the equation, that I can cancel the negatives, obviously, but this is going to be 5 over 6,912, and that would be my equation. And when you're done, there's a couple ways you can check these, right? So you know here you've got 3, 4, 5. You've got 5, power of 5, degree of 5. So your tails should be opposite, and they are. You can double check your roots, -8, -4, +6. Yep. Checking the y-intercept might be a little bit of work. I probably wouldn't go ahead and do that because you have to multiply this times 8 times 4 times -6 cubed. If you multiply all that stuff together, you should end up getting a -5. Last example. Okay, my roots. X equals -6, -4, -1, and 3. No triple roots, no double roots. My y-intercept, y equals -1. So now here's my equation. Y equals, give yourself some room for an A value, x plus 6, x plus 4, x plus 1, x minus 3. Here's your value of A. The y-intercept over the product of factors. 6 times 4 times 1 times -3. This one I would expect you to be able to do on an exam. There's a couple ways you can do it. You can take 4 times -3, that's 12. 12 times 6 is 72, so that's going to be -72. That's probably the easiest way, or you can take 6 times 4 is 24 times 3. That also gives you -72. We're just going to cancel those negatives, so it's 1 over 72. 1 over 72. Here's the equation. Again, a couple checks. It's a 1, 2, 3, 4th degree, positive. So tails both up. That makes sense. That works. Okay, so that concludes day 4. As usual, guys, reach out if you have any questions whatsoever. Thanks for watching, and we'll see you in class.